We got like 2 minutes. Yeah. Got like 1 minute. Okay, I guess we'll get started. So I'm VV Alien One, and I go by VV Alien on GitHub, just to switch it up a little bit. I work for Dark Rhino Security. I'm a senior threat hunter there. I get to do a lot of research. It's really fun. So this talk's going to be kind of simple, but this is essentially what it's about. It's about an old school problem that nobody's really, I've seen anybody fix. So essentially, basically, we'll start with networking 101. We'll get into a little some layer 2 stuff, but basically this is going to give us, the solution will give us basically visibility into lateral movement. But ultimately what it is, it's full client segmentation on a LAN. So this is very novel. There's not really going to be any exploits or 0 days or anything like that. So if that's what you're looking for, I'm sorry. So this talk is, oops, I apologize. This talk is not about Wi-Fi, IPv6, anything really above layer 3, some crazy subnetting, which you can do to somewhat accomplish this, any vendors at all. So I just wanted it free, basically. I don't want to have to buy something to be able to accomplish this, right? So to explore this issue, how to provide full client segmentation, we need to know a little bit about subnetting, a little bit about layer 2. We need to know basically what a managed switch does, a little bit about Linux, and how to use Wireshark, right? So essentially all we have to do is build a lab. Also, real quick, this is going to probably be a little bit short because, like I said, it's a very novel approach. So if you have any questions, please ask me because I can fully explain it, okay, to pretty much anybody. I can explain it to somebody who has basically no hacking experience, no real networking experience in pretty much 10 minutes. So any questions, please ask, okay? So we'll start with our lab, and essentially what we're trying to accomplish is full layer 2 segmentation on a LAN, and then let the clients be able to talk to each other so that we can pass it through and actually see and log the traffic and peer into it, right? So we don't have to tap everything out. So we'll build a lab, and our lab will be really simple, right? We'll have a router, we'll have a client A, client B, and we're going to add some colors because, it needs to, we need to be able to understand it a little bit, right? So our lab is essentially this, and you'll see INET and ILAN maybe a little bit in the slides there, and just so you're aware, INET is essentially your Ethernet 0, which connects, to your ISP, and ILAN is going to be your internal interface, which will connect to your switch, right? So everybody understand that? Yes? Okay. Like I said, questions, please ask. So, all right, so let's start with subnets. So subnets, if you ever look at subnets when you do like networking 101, it's all math, right? And it's a bunch of garbage because we all look it up. Like, I don't know how many times I've used, a little subnet calculator because I can't do it in my head, and I don't think really anybody does it in their head, right? So, serious, right? It's true. It is. It is. So this is the subnet table here, right? But essentially, honestly, all we really care about, and all I almost ever see, unless you're dealing with setting up, your external IP for your ISP, is these 3 subnets, right? Your /8, your /16, and your /24, okay? But that really doesn't tell us what subnets are, right? Because, we all hear it, and we know how to do the math. But basically, anything in a subnet talks directly to one another, okay? Directly, like completely directly. So you're not going to see any of this on your upstream firewall or anything like that, right? And that was really confusing me at first. I'm going to get to that in a little bit. So that's what subnets are. Now let's explore ARP just a little bit, and I'm not going to touch on it a whole bunch. So ARP is essentially this, right? So you have client A with IP 111 or 11 and with a MAC AAA, and it needs to be able to actually go out and essentially find out where 222 is, right? Or 22, sorry. So it basically requests out to everyone, right, which is broadcast FFF, okay? And then if client B is there on the same switch or it can see it in the same subnet, then client B will respond, okay? And it'll say, hey, I am that IP address, and I'm at this MAC address, right? Very simplistic, very easy. Like I said, there's more to ARP, but we're just going to concentrate on that. Very simplistic, okay? So now let's get into a little bit of switches. So this is sort of what confused me at first. When I started to explaining it to people, I had asked a whole bunch of people, do they understand how to do this? And nobody really said yes. And so that's what I found. Honestly, that's why I gave this talk. So I realized, though, while I was making these slides, why everybody was having a problem understand this. And the reason is because of these. These are not switches. These are routers, right? They might act somewhat like switches, but they're not. And that's why I personally had a problem understanding it, I guess. But I've also heard other people do it. So that is not a switch. All right, so switches come in two flavors. Okay, you have your managed, right? And you have your unmanaged. And unmanaged are just, they're totally dumb, right? Yeah, they are bricks, basically. They let anything through. You basically plug in, and it assigns IP addresses to all layer 2 for you, right? But with a managed switch, you can do a lot more. Okay, you can do protected ports, you can do VLANs, you can do PVLANs, all the QoS and all the other stuff that comes with it, right? Because there's a bunch of features that added in. Okay, so essentially, just there are two kinds of switches. So if you were to want to go out and buy one, make sure you get a managed one. Okay, and like I said, they come in all different flavors, and you can set them up all different ways. And we won't get into any of that, but just be aware, you want a managed switch. You do not want an unmanaged switch. Again, this is our lab, and so let's take a look at what a normal, simple ping sort of looks like in just a normal switch lab, right? So, in normal mode, we'll start, and we'll basically ARP out. So we're going to have client A basically ping client B, right? So the first thing it needs to do is it needs to ARP out. It needs to say, hey, who has IP address 10.10.22, right? And then next, the client B, if it's there and it sees it, it's going to respond and say, hey, this is me. I am here at the MAC address BBB, okay? Once it sees that, then we can send our ping, and it sends the ping directly to client B, right? And there's no way, so if this isn't a switch, and this goes into a firewall, you're not going to see any of this traffic, right, at all, whatsoever. So I know I'm using ping as an example, and we'll continue to use ping as an example. But just think of it more along the lines of, SMB or something like that, right? So client B responds, right? Hey, you ping me, I'm going to ping you back, right? Very simplistic. This is what you see all the time on just a normal switch, right? If you were to put Wireshark on it or tap it out or something, okay? So now to understand a little bit more about how we're going to segment it, we have to basically understand VLANs, okay? So VLANs kind of confused me for a while. But then I realized that VLANs are basically just a little small tag that's added on to every single packet, right? And if you've never seen it, check it out sometime. It's kind of interesting. Now, you can break out of VLANs. It is possible, but we won't get into any of that, right? So real fast, this is basically how you set up VLANs on a Debian box, and that's what we're going to use for example, is a simple Debian box. That's how I did this. And I do have a bash script that I'll release at the end, basically once I get back. So that's VLANs, right? So protected ports. Now, protected ports is something maybe some of you have heard of, maybe some of you not. But basically, all it is layer 2 segmentation, okay? So if you have two clients in a protected port switch, they cannot see each other at all whatsoever, all right? But you also need to choose an uplink port. So you need to be able to talk to the internet, right? So you have to choose one of your ports on your switches to be an uplink. Now, you can do with 2 ports, right? But one is typically the thing, right? So we're going to look in the lab what protected ports look like, right? So client A wants to ping client B, and what does it do? it comes out and it sends an ARP request and says, hey, who has 2222? And the router sees this, or the gateway sees this, and it doesn't care at all. Doesn't care whatsoever, right? It just sends out ARP, and because it doesn't have that address, it doesn't matter, right, at all. So it just sits there, and you're going to keep trying to ping out over and over again, and eventually it'll time out, right, and it'll just fail, okay? So that's what we want to solve, right, because we want all of our traffic to go up to the router and to be able to just basically log it, right? So this is what took me so long, to basically figure out how to do it, right? And finally, I eventually found a solution, and it's called local proxy ARP. Now, there's two kinds of proxy ARP. There is just normal proxy ARP, but there's local proxy ARP. And essentially what that says is that it will ARP for, it will basically proxy ARP, but only on a single interface, okay? Now, you can do it. The original proxy ARP essentially worked so that way you had a, if you had another client on your perimeter and you needed to basically pull it into your internal subnet, you could basically ARP it out, right? So this is how you essentially enable it. You just basically echo it into there, and there's a little history there as to where it came from, right? So we're going to take a look at how that works. Once we enable that feature, now we can essentially log all of our traffic and look into it, right? So with local proxy ARP, this is basically how it works, right? You're going to send out, client A is going to go out to ping client B, and it's going to say, hey, who has address 222? It's going to send it up to the gateway and the router is actually going to respond with its MAC address. And it's going to say, look, I know what you're looking for, but hey, that's actually me. And it's going to respond. It's going to say, I am that address. And then what's going to happen is you're going to send your ping, and you're going to send your ping up to your router and your gateway, and it's just basically going to forward it back down to client B. Client B needs to know where it is, so it's going to ask the router, the gateway, where it is. It's going to send it up. The gateway and the router is going to respond, hey, I'm right here. And everything's happy, and then your ping gets forwarded backwards, right? Your reply. Very simplistic, okay? So in a Wireshark packet capture, this is essentially what it looks like, right? Now, you'll notice, so this is client A, and like I said, I could walk through this, but I think you can take a look and see it, what it is. The ICMP redirect actually happens because the router knows that there's a shorter path for it, right? And you'll see that on client B. It will also do the exact same thing, okay? And on the router, right, you also see ICMP redirect, okay? Now, it's actually really easy to disable this, and I'll show you how in 2 seconds, but this is basically what we want to do, because now your router and your gateway has a full log of all that traffic. You don't need to go around, to your office to all these little switches and tap each one of them out, right? Which is essentially what you have to do if you want to detect lateral movement, right? Another really cool thing about this is it actually provides, it's essentially full microsegmentation. You don't have to actually do subnets anymore. You can put everything in one if you use this, right? But essentially, all it really is just the router spamming out. Every time it sees something within its subnet, it responds with its MAC address, and everybody's happy, right? But like I said, to do that, we have to disable ICMP. That's essentially how we do it. And then after we do that, everything works flawlessly. The only thing we have to do is basically make our IP tables rules. And that actually confused me for a little bit because I was not aware that you had to make the IP tables rules in the forwarding section, right? So that's basically how you do it. And also another thing too is logging on IP tables is really horrible. And that's how you can do it. I actually, the very simplistic way is basically copy the rule, put it above it, and then just log that, right? Everybody understand? So just so we are clear, completely clear, this is proxy ARP PVLANs. It's the setting in all Linux boxes since 2.6.35, and that's all it does. It just spams out its MAC address for anything in its subnet. That's essentially it. So I know it was a quick talk, I apologize, but I just kind of wanted to raise awareness so that everybody knew. So ask me questions, because I can explain it if there's any non-clarity. Yeah, go ahead. On the switch, so different switches have different things, right? So I used a gigabit switch, and it basically dropped everything down to 100 megabits. So because it has to do processing and everything like that. So you do have to get a good switch to be able to do it, right? But you can use a cheap switch as long as it's a managed switch. I've been using $40 ones for basically from China, and they work fine. They work fairly well, you know. But yeah, so you had a question?
Yeah, I guess, so what are some of the cool things that
So essentially, one of the really cool things that you can do, right, is you don't have to subnet any. So if you were to take a small business or medium business, right, you could essentially drop all of your subnets, all of your private VLANs, everything, and put it all in one single subnet, right? You could basically make your network flat again, and then make all of your rules on your upstream firewall, right? So you don't have to. Now, I'm not saying do that. What I'm saying is I would still like to see, you know, a little bit of segmentation there, right? So, you know, segmenting your servers and everything, but still, so for instance, clients almost never, ever, ever need to talk to each other, right? And you can put them all in the same subnet. You don't have to worry about it. You don't have to say these are the sales computers and these are the accounting computers. They can all go in the same thing because none of them can talk to each other at all, right? So one of the reasons, real quickly, is that this came about is because there's a zone, sort of a zoned approach, where if you're dealing with firewall, you have to make different zones and everything. And it can become a real hassle because you have to play a juggling act of, hey, this server needs to talk to this server, so it can't be in the same zone. You have to move it outside of it, but I want to be able to look at the traffic because I want to be able to look at the traffic. And it just becomes a juggling nightmare because if you don't have enough ports in your firewall, then you have to make concessions as to where you're going to go. But with this, you only need one port and one switch. So, yeah. Any other questions? Yes?
how would this work, you know, if I were in a situation where I'm trying to look at east-west traffic,
Yeah.
and I'm trying to move laterally between the environment, what can this do to help stop it?
Right. So, well, typically in lateral movement, if say you have a client box and in the same subnet you have your AD, right? You can't see that traffic at all. Like, unless you're logging on the domain controller or you're logging on the client, you won't be able to see it whatsoever. So you can essentially say, you know, if the domain controller should have, you know, say, you know, like an IIS server running on it or something like that for some sort of authentication scheme that you're doing, you shouldn't, and say, you know, a group of clients don't need to talk to you, you can essentially firewall that off on your main firewall, right? And you don't have to do it on the client or push GPO policy out or anything like that. Or if they're Linux boxes, you don't have to go in and make your IP tables rules. So, but yeah, you can essentially see everything. That's what you get, is basically full visibility into all the packets that are going in your network. So, any other, yes?
Is there any special configurations you can do with VLANs or subnets and stuff?
On your switch? Nothing. You just enable private VLANs. That's, yep. Because, so VLANs would be done on your router, but the private VLANs is actually almost done on the switch, right? So it has to do with the switching technology. Now, all switches are different. They kind of handle it differently, but yeah. So it's all done. It's all manual on the switch. There's no special configuration at all. Yes?
Are all the commands and codes out on your GitHub?
No, but they will be Tuesday of this next week. So I just need time to clean it up so I can release it. So I was going to post it, and I apologize. I had fun at the Offspring concert last night. So, any other questions? Yes? No? Okay. Well, that's it for me. So, thank you.